Today I will be introducing the basic concepts of intermolecular forces. I will not be going into the specific types of intermolecular forces in this video. If you are looking for that, check out my part 2 and 3 videos. Let's quickly review what an intermolecular force is. First, it is important to understand that opposite charges attract one another and that like charges repel. I will show this phenomenon through a simple animation. An intermolecular force is a force based on this concept. It is a force of attraction between molecules of opposite charges. An intermolecular force is what's responsible for the physical state of something, meaning that it is responsible for keeping solids and liquids together. Here is an example of intermolecular forces. I'll explain why in a later video, but keep in mind that H2O is a polar molecule with oxygen being negatively charged and hydrogen being positively charged. Oxygen and hydrogen have opposite charges, therefore they will be attracted to one another. The dotted lines represent intermolecular forces, that they are what's responsible for keeping the H2O molecules close to each other. In this image, they are packed together, and for that reason, the intermolecular forces are responsible for the liquid phase and solid phase of H2O, which is water and ice. Now, one big misconception is that intermolecular forces are the forces within molecules, represented by the straight lines in the image to the left. This is not true. The forces within H2O molecules are called covalent bonds, while the forces between H2O molecules are not. To restate, the opposites attract idea, the idea that oxygen is attracted to hydrogen only refers to the dotted lines, not from the straight lines. These bonds do not form as a result of the concepts of opposites attract. It is important to understand that you can break intermolecular bonds by adding heat or energy. You can also form them by removing heat or energy. By doing so, you can change the physical state of matter of something. So, imagine a time when you saw a change in the state of matter. For this video, I will be using the example of a pot of water on a stove. Let's take a look at the structure of H2O when it is in liquid form before we turn on the stove. It is shown by the image on the left. When we add heat, we break the intermolecular bonds that hold H2O together. So, what do you think the product will be if I add heat to this image on the left? The product would be a bunch of lone H2O molecules shown to the right. They don't have the same intermolecular attractions as the image to the left. Now, what do you think this is? It is the gaseous form of water, which is water vapor. Now, this should make sense. When I boil a pot of water over the stove, I'll get steam, which is the same thing as water vapor. What you do when you boil that pot of water is that you break the intermolecular bonds holding H2O together in liquid form. The result is H2O in its gaseous form. It is important to note that you do not break the covalent bonds. You would need much more heat to break these bonds. If these bonds did break, I would end up with hydrogen and oxygen gas when I boil water, which does not happen. So what we just saw is an example of how breaking intermolecular bonds changes the state of matter of an object. It is important to understand that you can form intermolecular bonds as well. For example, water will turn to ice by forming more intermolecular bonds if the temperature is low enough. Now, I haven't talked much about gases. I have drawn water vapor molecules above. My question to you is this: will gas molecules experience intermolecular forces? Pause and think about this. Now, when I was learning this for the first time, I thought no. After all, it seemed to me that each gas molecule is independent of each other, that they weren't attracted to one another, and because of that, there were no intermolecular forces. However, this is not the correct answer. Gases do experience intermolecular attractions. How is that? Remember, H2O is polar, with oxygen being negatively charged and hydrogen being positively charged. It is still polar here, even though it is in a gas formation. gases move randomly inside a container, and they will change positions when they collide with the walls of the container. We will represent that by adding arrows to the molecules to show their direction of movement, and we will also add in a container so our water vapor doesn't escape into the environment. Now, let's pretend that the gas molecules have had some time to move around. These things represent an impact which causes the gas molecule to change directions. Notice how these two gas molecules have moved to be very close to each other. Again, water is polar. Since these molecules are very close together, the positively charged hydrogen from this molecule can interact with the negatively charged oxygen from this molecule. What does this mean? It means that there are intermolecular attractions between gas molecules. This doesn't necessarily mean that an intermolecular bond is formed, since that would turn the gas into water. But it does mean that these two molecules will slow down for a brief moment, since their line of movement is interrupted with the intermolecular attractions. To conclude, gas molecules experience intermolecular attractions with each other. This prevents them from behaving like an ideal gas. That's all for now. I'll talk about the specific types of intermolecular forces in my other videos. If you were wondering about the intermolecular attractions in something that is non-polar, I will address that in the other video. Let me know your feedback and questions in the comments. Again, thank you for watching. Goodbye.